Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss kinematics of hot air balloon which is moving vertically upwards with constant speed. And we will answer past paper questions using different methods so you can have clear understanding about this type of problems on kinematics. For this question, it is given to us that a hot air balloon is moving vertically upwards with a constant speed of 3 meters per second. A sandbag is dropped from the balloon. It takes 5 seconds for the sandbag to fall to the ground. And question is asking us, we need to find the height of the balloon when the sandbag was released from the balloon. Let's try to sketch this problem because the best way to answer any questions in physics is to sketch. When we sketch any problem, we can visualize. When we can visualize a problem, then easily we can answer. Let's try to sketch this problem first. As you can see here, I have already drawn balloon here. So let me draw sandbag as well. So this is the sandbag. You can even write down here. So this is the sandbag. This is attached with balloon. The balloon is moving vertically upwards with a speed of 3 meters per second. So anything which is part of the balloon that also have the same speed. So in this case, sandbag also have the same speed, that is 3 meters per second. And sandbag is also moving vertically upwards with the balloon. That is very important point. For this question, we need to find the height of the balloon when the sandbag is released from the balloon. So it simply means that we need to find this height. In order to find this height, we need to study the motion of sandbag. So let me redraw sandbag. So this is our sandbag and this is the height what we need to find out. So let me label again. This height we need to find out. This is the height we need to find out. Now, initial speed of this sandbag, as we have already discussed, this is equal to 3 meters per second. And this sandbag will continue moving with this speed upwards. But this speed will decrease because there is a force of gravity that is acting on this sandbag. And finally, the speed of sandbag at certain height, that will be equal to 0. And then the sandbag will start falling downwards. So it will move towards ground and finally it will hit the ground. So let's say it hit the ground at this point. And the total time taken when it is released from the balloon to go up and to reach the ground, that is also given. And that time is 5 seconds, 5.00 seconds. As this sandbag, this is in free fall, we can also write down this is in free fall. It simply means that only force acting on this one is gravity. So the acceleration of this sandbag, that is equal to 9.81 meters per second, and that acceleration is down because gravity is pulling this sandbag downwards. And initial speed of this sandbag, that is also given, that is equal to 3 meters per second. We can also write down. And what we need to find out now is we simply need to find out the vertical displacement, means from here to here. This is the vertical displacement we have to find out. And that vertical displacement, this is equal to height. So this is height. Now we can also write down height is equal to vertical displacement of sandbag from the ground. So this is what we need to find. And the speed, initial speed is upwards. We can also use arrow to show that the speed is upwards. Now simply we need to use kinematic equations to calculate final value of vertical displacement. Before we use kinematic equations, we need to take one direction as positive, as in this case we are only talking about vertical motion, so we can take up positive or we can take downward positive. In this case we are assuming that downward direction is positive. As the downward is positive, so it means the acceleration is positive, and initial velocity, this is negative because its direction is vertically upwards. Now simply we need to plug in these values and we can find our final answer. We can simply use S is equal to ut plus 1/2 at t square, because we have u, value of u is given, t is given, and a is given. T is the time taken from point of release for this sandbag to go up and then come back to the ground, means the total time taken is given. So that's the reason we can calculate vertical displacement from here to here. U is given, we can just plug in value of u, we can just plug in value of a is 9.81 and the time is 5. And our final answer will be 107.625 meters, or we can simply say this is about 108 meters. So our final answer for this question is B. As we have already discussed motion of this sandbag, now we will use velocity time graph to find the vertical displacement. We have discussed that its initial speed, this is equal to 3 meters per second, so we can write down here, and the speed of the sandbag at the maximum height, that will be equal to 0 meter per second, we can write down at this point. Now first of all, let's try to find out the time taken by the sandbag from this point of release to the maximum height. So that time we can simply calculate by v is equal to u plus at. In this case, v is equal to 0 and the u, if we take upward direction as positive, let's say upward is positive, so the u, this one will be positive, but acceleration due to gravity, this will be negative because acceleration is downward, so this will be negative. Now we can simply plug in values here and we can find out value of t, and a in this case is negative 9.81 times time. So the value of t we can find out, the time taken from point of release to maximum height, that time taken will be equal to 0.31 seconds. Now we understand at this point velocity is equal to 0. If we need to find out the velocity when it hit the ground, let's say that velocity is v1. Now the total time taken is given, that is 5 seconds. So the time taken from this point to this point, let's say that time taken is t1, and t1 will be equal to 5.00 minus 0.31. So simply we can say that is equal to 4.69 seconds. Now at this point we have the value of the v, final v we have to find out, and we have the time taken. So again we can use v is equal to u plus at. U plus at. In this case we will take downward as positive. So final v1, this is we need to find out. Initial value of u means this v, this is simply is equal to u, so we can write this is equal to 0, and value of a is given, that is 9.81 because this is in free fall, and the time taken we have, that is 4.69 seconds. So if we plug in values, we can find out the value of v1, and v1 in this case is equal to 46.0 meters per second. We can write down here v is equal to 46.0 meters per second. So this is, now that's all we have done. All simply we need to sketch velocity time graph. Now let's try to sketch velocity time graph. In order to sketch velocity time graph, we need value of u, means we need value of initial velocity, we will need value of t, we will also need value of v1, and also we will need value of total time taken. In this case, total time taken for this sandbag to go from point of release to reach maximum height and to come back to the ground, this is equal to 5.00 seconds. Now let's sketch v velocity on y-axis. So this is velocity on y-axis and this is in meters per second, and time is on x-axis and the unit of time is seconds. But one thing we need to understand is that, as in this case our acceleration is constant and direction of acceleration is downwards, so it means that the gradient of velocity time graph, this has to be constant. We also need to consider one direction as positive, let's say downward as positive, because our vertical displacement is downwards from point of release, so we will take downward as positive, so we will get positive answer for vertical displacement. Now simply we need to sketch. As you can see, in this case we have initial value of the velocity. Initial value of velocity has to be negative. Why it has to be negative? Because we have taken down as positive. That initial value of velocity means the velocity is vertically upwards. This is upwards, so initial velocity is negative because direction is opposite. And then after time t means at this time 0.31 second, the v is equal to 0. I mean, this is the peak, so we can label this one. This is the peak, means this point. And the value of v1 we have at this point, and value of v1 we can also write down here. This is equal to 46.0 meters per second. And the time, the total time at this point, this is equal to 5.00 second. Now if we look at this area, this one, area between v and t, this is displacement from this point to this point. This is the displacement, and this displacement is negative because we took down as positive, so we can calculate this area. So area of this triangle, simply we can find out. This is 1 by 2 and the velocity multiplied by time. Time is the base, so final answer in this case will be equal to 0.465 meters. But this is negative. This is negative, and this is the area. I mean, this displacement is from the peak to the ground, so this is from peak to the ground. We can also say that this area is equal to S1, and let's say this is equal to S2, and so we can calculate area of this triangle, and that is equal to S2. So S2 in this case is equal to 1 by 2, and this will be 5 minus 0.31, means this is 5 and this point is 0.31. Height of this triangle, this is 46. So our final answer will be 107.89 meters, and this is positive, so we can write this displacement is positive. So this is positive if we take from here, so this is positive. What we need to find out, we need to find the displacement from this point to this point, so we can also say that is equal to S. So S simply in this case is equal to S2 minus S1. So we can write down 107.89 minus 0.465 meters, and our answer will be in this case 107.425, or we can simply say it is very close to 108. We can write down about 108 meter, and this is our final answer.